Hello everyone, today we're going to discuss about periodic table. As there is a lot of information are provided in the periodic table. But first I would like to start to tell you that there are about 118 different elements known. One thing that you should keep in your mind that the periodic table, the elements in the periodic table are not arranged randomly. Instead, they are arranged very systematically. It's based on their atomic weights, based on their reactivity, based on their physical and chemical properties, and also based on their sizes. So it's like a periodic table is pretty much like a GPS. If you want to go from one place to another place, a GPS would help you where your destination would be. So a periodic table is just like that. It tells you which element belongs to where and what kind of character that it has. First, I just want to start with the big section, a metallic section, a metallic element. This part right here is called a transition metal. This part here is called alkali metals. Alkali metals. Alkali means it's a Greek word. It means like ashes. The reason why it's called alkali metals, the main components of alkali metals like sodium and potassium were isolated by ashes. From ashes by the early chemists, and then the name derived from the Greek word. And then you have something called alkaline earth metal that is on this group here. It's called alkaline earth metal. These are called group 2 elements, alkaline earth metals. And we're going to break down all these main groups of elements. And the yellow part here, they are called transition elements. Transition elements. What's interesting about transition elements is that they have a multi-variable balances. In other words, there are elements, most of these elements have more than one balances. If you take iron, for example, you have iron here. Iron has, the common iron has a charge of +2, and in some cases you'll see iron with a charge of +3. So the same element will have different charges, so we call them transition elements or multivariable balances. Then we have something called noble gases here, or inert gases. They are not that much reactive. I'll tell you the reason why we call these noble gases. Noble gases, sorry for I don't have enough space here to write, or inert gases. Then we have the purple color. This purple color here called the halogens. Halogens, and halogens means salt formers. It's again a Greek word, salt formers. Salt formers. Most of the halogens they can form salt when they react with alkali metals. Say for example, sodium reacts with chlorine, it gives you a common salt called sodium chloride. So most of the halogen families like fluorine, chlorine, bromine, iodine have these kinds of properties. And then in between metals and non-metals, there is also something called metalloids. These metalloids pretty much have something like a green color. So it goes this way here. They are sometimes they are acting as metals, sometimes they are acting as non-metals, and we call them metalloids. Now, one thing about metals, as you see here, almost like 90% of the periodic table is made from metals. And how do we define metals? A metallic character, they are more shiny, they are lustrous, malleable, and their oxide forms a basic ionic solid. I'm going to explain what does that mean. And they tend to form cations in aqueous solutions. In other words, if you have sodium oxide, for example, the sodium oxide reacts with water, it gives you something called alkaline solution or basic solution, which is sodium hydroxide. That's one of the difference between a metallic oxide with non-metallic oxide. For instance, if you have nitrogen dioxide or carbon dioxide, these are a non-metallic oxide. When they react with water, they basically gives you, when nitrogen oxide reacts with water, gives you nitric acid, it's an acid, or carbon dioxide reacts with water, gives you a carbonic acid, which is H2CO3, which is a weak acid. One of the things that metallic characters increases down to groups, that's a very important point. The vertical column, when you have a vertical column, that's called a group. Okay, this is a group. And a horizontal row, when you look from left to right, the horizontal row, we call this period. These are two important terminologies that we need to understand. Groups, which is the vertical columns, and period is a horizontal row. So one of the things that I would like to say that metallic character increases as we go down to the group. So let's say someone might ask you a question, if you want to compare sodium versus francium. Now francium is on the bottom. You see francium is on the bottom, sodium is somewhere here. Sodium is here. So francium is more metallic than sodium because of the position of francium is located in a group. So what it means is as you go down to the group, the metallic character increases. It's not only that, metals also have the size of the atom is also increases as we go down to the groups. That's also another point that we need to know. So someone might ask a question, okay, you know what, I have lithium, which is here, and I have cesium, which is here, so which one is bigger? Cesium is bigger than lithium. So the size of the atom increases, the metallic character increases. Another thing that we need to know in a group is that the ionization energy. Ionization energy. Ionization energy. The simplest definition of ionization energy is that it's the energy that's required to remove a valence electrons from an atom, from a neutral atom. So again, the ionization energy decreases as we go down to the group. I'm not talking about group 1, I'm talking also about group 2A. Most of the elements in the periodic table have such characteristics, especially when it comes with metals. Metals have low ionization energy, and their energy decreases as we go down to the group, which is a sign that their reactivity increases. Their reactivity increases. So this is, as you see, as you study deeply about the periodic table, you see a lot of information. It's not randomly arranged. They are very much systematically organized. Like I said earlier, a periodic table is like a GPS. It has a lot of information. So in this section, we're not going to discuss about all the 118 these days, I'm sorry. 118 elements, but for our chapter we pick certain groups of elements, so I'm going to discuss these groups step by step. So like I say, we're going to discuss about some of the main characteristics of elements group 1A. I'll start with group 1A. Group 1A are called alkali metals, and alkali metals are called group 1 elements, the A group's elements, and I'm going to tell you the names of the elements located in group 1. By the way, alkali means like ashes, like I said earlier. It is a name given by the early chemists, since most of the common elements of alkali metals like sodium and potassium were isolated from ashes by the early chemists. So members of the alkali metals are starting from lithium, sodium, potassium, rubidium, cesium, and francium. One thing that I would like to tell you, when you write elements, if you have two letters, the first letter is always has to be a capital letter, the second letter has to be a small letter. That's a rule, okay? And if you have just one letter, the first letter, whatever letter that you have is always a capital letter. So the alkali metals, they behave similarly. They are shiny, they are soft, they have low melting points in terms of their physical property, and also they have a low density. As you know, the mass, as we go down to the group, mass increases, their weight increases, their size also increases. Size also increases. That's also another important thing. If size increases, it's obvious that the density is going to be decreased, because density is basically mass over volume. So if you have a large volume or a large size, the value of density will be increases. The other chemical characteristic of alkali metals is that all of them, they react violently with water. So for example, if you have lithium react with water, you will get lithium hydroxide plus hydrogen. This is called the alkaline solution. Alkaline solution, or sometimes it's called a basic solution. By the way, it's not only lithium would have such characteristics. It can be for sodium, it can be for potassium as well. So when sodium reacts with water, you will get the same solution, which is sodium hydroxide plus hydrogen. Or potassium reacts with water, it gives you potassium hydroxide plus hydrogen. So the reaction is very aggressive reaction, is a violent reaction. That's the characteristics of group 1A elements. So in general, we can say that, let's assume that you have X. X can be represented the alkali metals. It can be any member of the alkali metals. So when X reacts with water, it gives you XOH plus hydrogen. So OH is a sign of, if you have OH in a solution, we call it alkaline solution. It's called alkaline solution. So I just cut for you just to show you about group 1A elements. This is a group 1 element. It's from the periodic table. So you can see that hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. And you can also see some numbers on the top here. Okay, lithium has 3, sodium has 11, potassium has 19, rubidium has 37. By the way, these numbers are called the number of protons. Okay, number of protons, and sometimes they are called atomic number. Atomic number, and the atomic number increases as we go down to the group. And also on the bottom, maybe it might be very hard to see it, but you can see the atomic weight. The bottom number refers to atomic weight. Atomic weight, like I said last time, it is a weighted average mass. Is a weighted average mass of all the isotopes of that particular element, the weighted average mass of all the isotopes. Okay, so please don't get confused with the difference between atomic weight versus mass number. So a lot of times they look like the same, but in reality they are not the same. The atomic weight is the weighted average mass of the isotopes, but the mass number is simply the number of protons plus the number of neutrons. It's like a simple, straight and forward linear equation. But atomic weight is the average mass of the isotopes. You can also see that the size of the atom increases as the number of protons increases. Because when we're talking about the mass number, if you have the number of proton, if the number of proton increases, obviously the atomic weight also increases. That's one of the things that we can able to tell about group 1A. And the size of the atom, like I said, it increases. Also, the alkali metals, they are highly reactive, and you never found them free in nature. In other words, you can't just get sodium per se or potassium. Mostly they are reactive with oxygen, and you'll get them as sodium oxide or potassium oxide or lithium oxide. They are more reactive, and they form something like a white coating when they react with oxygen. One of the other things that about alkali metals, they emit a characteristic colors when placed in a high temperature flame, and they produce different colors. I know most of you are pretty much familiar with something called a firework in July 4. When July 4 comes, you remember about or you can see a firework. The firework is actually the result of excited electrons of these atoms when they get energy from the outside sources. What's happening is that the ground state is eventually transforms into excited states. In other words, electron from the inner core shell will jump to the next level, and then that time they emit energy when they turn into ground state. First of all, they absorb energy and they move to the next energy level, but they are not going to stay there, and they will be back. This happens within a fraction of a second, and when they get back to their original spot, which is the ground state, they emit or they release energy, and the energy actually can be shown by colors. So say for example, sodium can produce a yellow color. Potassium, I believe, is produced a blue color. Lithium can be produced I believe a red color. So if you have a good proportion of those elements combining together, you can see such a vivid color, such rainbow colors in the sky. That is a combination of the right combination of all these various elements. So, the firework is actually the result of getting electrons excited. When I say electrons, I'm talking about the electrons from the outermost shell of an atom. Well, the next group is called Group 2A. Group 2A are called alkaline earth metals. Alkaline earth metals, they are Group 2A. And members of the alkaline earth metals are beryllium, is here, magnesium, calcium, strontium, barium, and radium. Again, notice here that the first letter is always a capital letter, the second letter is a small letter. Again, since they are metals, they are mysterious in nature. They are shiny or silvery. Now, compared to alkali metals, they are less reactive than Group 1A. That's another thing that we need to also notice here. So one of the questions, maybe someone might say, if you like to compare sodium ion versus calcium, naturally calcium is less reactive is less reactive than sodium ion. Okay, it's because of its position in the periodic table. Okay, and when it comes to reactivity nature increases down to the group. So as you go down to the group, reactivity nature increases. So like to write here for you, reactivity increases. So like if you like to compare beryllium ion versus barium, barium is more reactive than beryllium. Okay, one thing that I would like also for you to let you know that the charge of the ions is +2. All the ions in alkaline earth metals have a charge of +2. What it means is that all of them will lose 2 electrons. Lose 2 electrons. Actually, the idea of losing electrons is that metals are basically, they lose electrons to be stable or to achieve octet. Like let's say if you have sodium, a sodium ion is a +1 charge, or lithium has a +1 charge. What it means is that they lose 1 electron. They lose 1 electron. Remember that the idea of lose or gain is come from something called ionization energy. Like I said earlier, ionization energy, it is the energy that is used to remove electrons from a neutral atom. When I say electrons, I'm talking about the valence electrons, which is the electrons in the outermost shell of an atom. Okay, so basically metals have, this is a general point I want you to take into notice, that metals have low ionization energy. Low ionization energy than nonmetals. Please notice it, that's very important to remember. We're also going to discuss about group 6A, group 7A, and group 8A. So as we go from left to right, please also remember that we go from metallic group to a non-metallic group. So the next group is called group 6A. It's called the oxygen group. The oxygen group. And as you see from here, oxygen is the main element. It's found on the top. That's oxygen. Then you have sulfur here. And you have selenium here. And tellurium, and lastly you have polonium. Now what you can notice from here is that as we go down to the group, metallic character increases. That's one of the points that we need to remember. A metallic character increases. This happens in group 1A, in group 2A, and you can also see here in group 6A, even though group 6A are non-metals, right? But as we go down to the group, the metallic character increases. Oxygen is a non-metal, obviously. Sulfur and selenium, these are non-metals. Tellurium is a metalloid. It's acting as metals and non-metals. And finally, you have polonium, which is a radioactive element, which is a metal though. So this shows you that as we go down to the group, you go from non-metals to metalloids and to metals. This is a good indication that the metallic character increases as we go down to the group. And oxygen has a tendency to attract electrons from other atoms, so oxygen is classified as a powerful oxidizing agent. It's a powerful oxidizing agent. In other words, oxygen would help other substances to lose electrons, but oxygen itself doesn't lose electrons. Oxygen gain electrons, but oxygen helps the other metals to lose electrons, or other substances to lose electrons, and then it's called it is a powerful oxidizing agent. Chemically, about group 6A, all group 6A elements forms a charge of -2. So I'm going to put like X to identify any of the element in group 6A, maybe like X here, and put -2. Okay, -2 means that they are gaining 2 electrons. Remember, so far we were discussing about losing electrons, but now we are talking about gaining, because nonmetals are not lose electrons, but they are gain electrons. So someone might ask a question: why do nonmetals, especially group 6A, gain 2 electrons? So the valence electrons for group 6 is 6 electrons. So in order to achieve octets, they need 2 more electrons. So they have to gain from somewhere 2 electrons to become 8. That means the outermost shell has to be somehow fulfilled, and we call this rule the octet rule. So octet means having 8 electrons in the outermost shell. So the next group what I would like to discuss is group 7A. Group 7A, they are called halogens. I would like to give you the definitions of halogens. Halogens means salt formers. Salt formers. So most common elements, like a most common salt, which is sodium chloride, would be a good example here. Sodium chloride is composed from a sodium ion from the alkali metals. Okay. And then a chloride ion from the halogens. So that produces sodium chloride. So most of the halogen families, like fluorine, we have fluorine here. F stands for fluorine. Okay, Cl stands for chlorine. Br stands for bromine. And I stands for iodine. And At stands for astatine. Okay. Again, one thing that you noticed that the metallic character increases. Metallic character increases as we go down to the group. Okay. A good example is if you compare fluorine versus astatine. Okay, astatine is here is astatine, it's a radioactive element, versus fluorine you have here on the top. Fluorine is a nonmetal, astatine is a radioactive element. All the halogens are typical nonmetals, and they are also, I just want to let you know that they are a diatomic molecule. So naturally you couldn't find fluorine as a single state, but fluorine as subscript 2, which is tells you as a molecule. So you have fluorine, you have chlorine, bromine, iodine, and astatine. For good reason, we're not going to discuss about astatine too much, because astatine is a radioactive element, so we'll not pay a big attention to astatine. So we're focusing more of to fluorine to iodine. One thing about bromine is a liquid. Iodine is a solid at room temperature. You can see that the number of protons are increasing as we go down to the group, and if the number of protons are increasing, it's also true that the number of electrons are increasing too, because protons and electrons, they are they are a direct proportion to each other. So there is a great deal of attraction between chlorine and bromine, because bromine has a large density of electrons, so it's becoming a liquid phase. And then becomes iodine. Iodine has a number of electrons of iodine is increasing with the that has actually impact for the electrostatic attraction. So what's the result? The result is that iodine is a solid. Do you see? Iodine is a solid. Because a solid has, when the electrons are coming together, when you have a huge number of electrons and if you have electrostatic attraction, then that turns into a solid. Versus fluorine and chlorine. Fluorine and chlorine are gases. They don't have too many electrons. So there is no a big deal of attraction of electron there. So one thing that makes a substance solid, liquid, or a gas is based on the electrostatic attraction. That's one thing that we have to pay attention here. Out of the halogen families, actually chlorine is the most industrially useful substance. It is often added to drinking water, to swimming pool, to remove some of the bacteria, and when it's added to water, when it reacts with water, it forms something called hypochlorous acid. It's called hypochlorous acid. The hypochlorous acid is chlorous acid. It's the one that is used as disinfectant to kill the bacteria. So the chemistry of halogens is dominated by gaining electrons. So all the halogen families, let's take for example, I'm not going to say chlorine or fluorine, I can just say X2, which is represented one of the halogen families. So when it interacts with the halogen families, when X2 interacts, or it is the chemistry depending on by gaining 2 electrons, and it forms a -1 charge. A -1 charge. Remember, a -1 means that they are in group 7. Let me write this down. Group 7. What does that mean? A group 7 means they have 7 valence electrons. So to achieve or to be stable, they may need 1 electron. So they have to gain 1 electron here. So that's the reason that all of them, when they react, they form a -1 charge. So chlorine has a -1 charge, so does fluorine, so does bromine, so does iodine. All group 7 elements, when they interact with other groups, they form a charge of -1, which means they gain 1 electron to achieve octet or to be stable. So the last element which I would like to discuss is group 8, group 8A. In most literature you'll see them as noble gases. They are helium is here, that's called helium, and this guy here is called neon. We have argon, krypton, and xenon is here, and the final element is radon. Now, one thing about the group 8A elements that we should know is that they are all nonmetals and they are a monoatomic. I would like to tell you what monoatomic means. Monoatomic means that they are single atoms. Unlike the halogen families, if you noticed, the group 7A, they are diatomic molecules. So you don't see them as a diatomic molecule. So when we write them as helium or neon, argon, krypton, xenon, and radon, because they are all monoatomic. And about group 8A, they are notoriously unreactive because their valence shell, the s orbital and the p orbitals, are completely filled. They are completely filled. So because of that reason, they don't need to react with any other substances. The ionization energy decreases down to the group. So when you go down to the group, their ionization energy decreases. Ionization energy decreases. It's sometimes hard to see that the noble gases have ionization energy, but experiments show that there is ionization energy, and then there is a possible compounds of radon or xenon can be formed actually with fluorine. Fluorine is a powerful oxidizing agent, so you may have in some literature, you may be familiar with xenon tetrafluoride or xenon hexafluoride compounds. These are the possible compounds that can be done even though the noble gases are unreactive, but because of the nature of fluorine, which is a powerful oxidizing agent, because of the nature of xenon has low ionization energy, experiments proved that these kinds of compounds can be formed. Other than that, the group 8A or noble gases are unreactive. In other words, they achieved octets. They are achieved octet means they have 8 electrons in their outermost shell. So this is all about the groups. Remember that we discussed about periodic table. The big portion of periodic table is metals, metalloids, and non-metals. Metals have a lustrous nature. They are shiny. They are silvery. Non-metals do not have such characteristics. Metallic oxides, they form alkaline solution, whereas non-metallic oxide, they form acidic solutions. That's very important to know. So if you have sodium oxide, for example, when sodium oxide reacts with water, it forms sodium hydroxide. It's alkaline solution. If you have nitrogen oxide, which is a non-metallic oxide, reacts with water, it forms nitric acid. So that's one of the difference between metallic versus non-metallic oxides. Metals generally lose electrons. Metals have low ionization energies, whereas non-metals gain electrons, and non-metals have high ionization energies. That's the main difference in the periodic table. And the periodic table is very important. It's like a GPS for chemistry because it tells you the elements are not arranged randomly. The elements are arranged very systematically in terms of size, in terms of reactivity, in terms of physical and chemical properties. Thank you, and I hope you like this video. And if you get time, please review it and share with your friends, and also like us. Thank you very much, and I'm going to see you on the next video.